Okay, so let's look at the last item. Let's look at the last item. Uneb Uce math, item 6, 2024. The last number as you're winding up with the paper. All right, it was a number which was a bit simple, and I know most of those students who went in for it successfully managed to pass it. All right, so we have your brother wants to design a children's playground. The playground will have a triangular garden. The playground will have a triangular garden. Will have a triangular garden. So therefore, let's also start getting our sketch. The playground will have a triangular garden. The playground will have a triangular garden. All right, so I will have it as this. This is our triangular garden. Okay, we'll have a triangular garden. Triangular garden and the circular fence around the garden. And the circular fence around the garden. So, circular fence around the garden. Circular fence around the garden. So this one here is a fence, like this. This one here in the middle is a garden. It's triangular, okay. Okay. The two sides of the triangular garden will measure 50 meters and 70 meters. The two sides of the garden will measure, remember this is our garden, so I will call this one to be my 70 meters, and this one here to be my 50 meters. We'll measure 70 and 50 meters, and the angle between them is 45, meaning that the angle here is 45. Okay, maybe this one is garden, that one there, so that you can have that space. All right, good. So your brother also wants to construct a circular fence around the garden such that the circular fence perfectly touches the three vertices of the triangle, like the way you have done. Okay. Your brother intends to put pavers in the region outside the triangular garden, but inside the circle. So intends to put pavers outside the triangular garden, but inside the circle, like that. The pavers can appear in that format. The pavers can appear in that format. Now let the shaded region be the area taken by the pavers, okay? And maybe I'll say this one here is for, okay, pavers, good. All right, now the saying, your brother intends to put pavers in the region inside the triangular garden, but outside the circular fence. Each square meter of pavers costs this, meaning that 1 meter squared of a paver costs that. This is what it means, that 1 meter squared costs shillings 35,000 of pavers. Right. Okay, now the saying, your brother needs help in identifying the type of triangle represented by the circular fence, circular garden. So they want to know which type of triangle is that, and we shall come to see. Coming up with an accurate design of the playground as well as the cost. So we must come up with the accurate design. The design is there in our sketch, as well as the playground and the cost of buying pavers. No problem. Part A, task the same. Help your brother to construct an accurate design of the children's playground. Now, the sketch of the children's playground is this. Let's go into getting the accurate. Now, to get the accurate, you must come and play around the scale. You must come and play around the scale. Now you can say, since this one is in meters, but your rulers you have are in centimeters, you can say, let 1 centimeter represent. Now you can choose any number which can divide this 50 and the 70. Me, I will choose, let 1 centimeter represent 2 meters. Let 1 centimeter represent 2 meters. And maybe also allow me put there A, B, C. There's no problem. Now it means that AC is 50 meters, divide by 2. That's what you do to get 25 centimeters. This is what I'm using for. You can choose 10, depending on the kind of type of rule I'm having. The one I'm having, when you put 10, it will appear very, very small, but they're all correct. Any scale you use, one can use 5, 10, depending. So here we have AB, now be 70, divide by 2, which will give us a 35 centimeters. This is according to me. For you can take 5, you can take 10. They're all correct. Good. Now we have that. I've converted this. Why? Because the ruler you have is in centimeters, not meters. So you have to change it in centimeters. You let 1 centimeter represent anything. Please don't go by the fact that 1 meter is equal to 100 centimeters. To be a bit hectic, take this. Okay. After that, now let's go into the accurate drawing. Now here, it is just like from the sketch, you are meant to circumscribe a triangle. So you begin by drawing a triangle. Most students made a mistake. They were drawing the circle first, then a triangle second. No, start with a triangle. And what you do, we have this line here is of 70 centimeters, same as 35 here to here. So let's now go and say, from there I'll come here and I say, accurate drawing. Please, a title, you can formulate it. You all know how to state the title. A short drawing showing the children's playground. No problem. Okay. Now, still in constructing this, let's begin with our straight line. Let's begin with our straight line here. We have begun with our straight line there. The next, since my 70 is same as 35 centimeters on a ruler, I've used that scale. So what I'm going to do, I'll now come and get my ruler. Please, I have my instruments, the ones I'm using for measuring. So therefore, come and measure off 35, because 35 stands for 70, 35, 35, here we are. There like that. So 35 is here. Come and put here. Make a marking there. Come and put here. Make a marking there. So, in simple terms, this is your A, this is your B. Please, I've chosen to put there the letters such that we can easily see what we are doing. There's no harm in that. Okay. Now, next, you realize that in this triangle here, we have an angle 45. We have an angle 45 there. And how do we get an angle 45? We draw 90, then we bisect the angle of 90. So let's do an angle of 90 here. Let's do an angle of 90 here. So we want to do an angle of 90 here so that we can get the 45. So put here like this. Put here like this. Make an arc there. And also make an arc there. Oh, I'll remove this. Okay, I'll make an arc. Sorry. I'll make an arc there. Make an arc there. Then also make an arc there. Okay. So make an arc there and arc there so that you can construct an angle of 90. Please, I put here, I draw an arc and even an arc this side. From there, you come and now stand at this level. At this level, draw an arc up. At this level, draw an arc there. The next, you now come and get your ruler so that you can draw dotted lines. Why are we going to draw dotted lines? It's because it is not the angle we want. So come and put here like this. We draw dotted line easy. Okay, dotted line is so. We're going to have it there. Okay, that's now our angle of 90. Why I made it dotted is because it's not the one we want. We want 45, but you only have to pass via the 90. All right, now I come back. Here, I have to bisect this angle. So bisecting the 90, I'll come and put here, like this. Make an arc on there, and also make an arc there, like that. I'm aiming at constructing this 45. So what I'll do next, come and put at this arc. Then you can draw in front in that space, and also put here and draw like that. So that's the 45 you want. You now get your ruler and join. Get your ruler and join. So this is all right. So this is now, since this is the 45 you want, I will just draw a solid line, not dotted again. I'll just draw a solid line, not dotted. Oh, Okay, good. So that is now our 45. You can now name it that now. This is now our 45 degrees. Don't forget this was okay 35 centimeters as per our chart drawing. But when you check it back, you see that it gets you to 70 as per the scale we have there. Now here, from here up to here is 50. But the 50 gave us 25. So I'll come and mark off 25 there. So 25, you get your ruler and measure off 25. So measure off 25 from here. We're going to have, all right, good. So 25 you're going to have here. Put a mark off there. That's what the marking will be. And where that marking is our point C. That's now our point C. The next what you do, since, look, we now have this, we have this, but we are missing this other one. So you just come and join this to that. So let's now join them. So come and join. All right, so join. All right, finally, I have joined, and now we have our triangle. Remember, this was 25 centimeters as per the actual drawing. All right. Now, next what we're going to do is, now let's see how we can circumscribe, or how can we put the circle outside. Now to circumscribe, please, what must you know? What must you know is, shall we say, bisect any two sides. Bisect any two sides. What do you mean by sides of a triangle? There is side AB, there is side BC, there is side AC. So bisect any two sides. You can decide to bisect this, that, or this, and that. Your choice. Personally, I will bisect this one and this one. Then I shall be able to circumscribe. All right. Maybe before we move any further, let's answer this question. They're saying, identify the type of triangle represented by the triangular garden and give a reason for your answer. Remember, I have very many types of triangles. We have one. We have an isosceles triangle. An isosceles triangle has isosceles triangle. Isosceles has when these sides are equal. Okay? And even the base angles are equal. Then you have what we call equilateral. Equilateral means that all sides are equal and even the angles are equal. So let's see, it should be between these two. Let's see, by measuring, of course, the sides. Let's measure the sides and see. We know this. Now this one can no longer be equilateral. It can't be equilateral. Why? This is not equal to this. Let's confirm whether this is equal to this, so that you can now call it isosceles triangle. So measure here to that point. Okay, transfer to your ruler and see what it really gives you. Oh, lucky we are. It is 25, by the way. Lucky we are, it is 25 centimeters. This is equal to that. So therefore, it means that you shall say it is an isosceles. Is an isosceles triangle. Comma, why? It's because now it means that here, if you measure this angle here is also equal to 45, you can say because the two base angles are equal. You can take that. The two base angles are equal. Base angles are equal. We have successfully answered that. Now let's go about the circumscribing. Circumscribing bisect any two sides. So to bisect any two sides, I want to bisect this side. And I'll put here, since this area is congested, okay, well, I can put around here. Okay, since this area is congested, I'll put it somewhere up. Make that arc. Be careful, the arcs, be watching them so that you don't get lost. Put here. So now to bisect this side, you stand at east extreme end, make an arc, stand here, make an arc, then get a ruler, dotted lines. So get a ruler and put dotted lines here. Therefore, you're going to have you have to be accurate like that. All right, good. Then next, come on, personally, I'm going to bisect this side, and its axis will be this side. I'm trying to avoid the congestion of the axis. So put here, to bisect this line BC, I'll stand at B, make an arc, stand at C, make an arc. Then draw a dotted line in between them. So I'll put here an arc, here, an arc. Then you draw a dotted line passing through this and dividing this line into two equal parts. Now, some people prefer this. Some people prefer this always. After making an arc there, you also come and make the arc this side. I'm avoiding the congestion, but I think for accuracy, let's use it. Right. So it will be like this for accuracy, so that this passes through this. Or you can only make this one. However, that will bring some errors in your drawing or in your construction. So I'll put this at that. Shall I remove this? That is passing through that area. Okay, now you realize that they are meeting around here, so the center of the circle will be there. Now, unlike the inscribing, with this, you can just go direct. You don't again need to draw the other line which gives us the radius. So, to circumscribe, to put a circle outside, we shall now come and say, this is now our center. Our center of the circle will be here. Our center, where the two lines meet, this one, this, after bisecting this line, we have that dotted line. Bisecting this, we have this. So where they meet is where the center of the circle is. So, you put there, then later, you come and adjust at any of these edges. Adjust at any of the edges around there. Then you can now draw your circle. Can now draw and now draw. Don't force life. Don't force life. Don't force life, please. It's not good to force life. You just have to be accurate with this. All right, and there we are with that. So we have already inscribed, rather circumscribed, and that's how it was meant to appear. And our sketch and that is that they can a bit correlate. All right, now let's go to part C. Determine the amount of money needed to buy the pavers. Determine the amount of money needed to buy the pavers. So here we shall say solution. The amount of money needed to buy the pavers, we know that, but 1 meter squared is equal to 3,000. No, is it 35,000? 35,000. Anyway, I'm not sure of this. Let me check. Okay, yeah, 35,000. So 1 meter squared is equal to that. And you look at this. Which unit is this? This is a unit for area. So therefore, it means that you have to come and get the area of this. Now, the pavers are only taking over this area, this shaded part. So shall I say now area of shaded part? Area of shaded part is equal to, now do you get area of a shaded part? You say area of, which one is the biggest shape here? It is a circle. Area of a circle area of a circle minus area of triangle. Allow me use that kind of English. Okay. Area of circle minus area of triangle. To get area of shaded part, because when you get the area of a circle minus the area of a triangle, you get the area of those pavers. Now, area of a circle, how do we get it? Area of a circle, that will be 3. Area of a circle, take note. Area of a circle is pi r squared. This is a circle. Now, area of a triangle, an isosceles triangle, area of an isosceles triangle is equal to a half BC sine of A. Is a half BC sine of A. I think let's just put them direct. So pi r squared minus a half BC sine of A. Now, I'll explain this. Let me bring that triangle. If I draw it for you here, like this, it is, now you name it as A, B, C. Now, there's capital and small. So, if you have here A, capital, small a will be there. If you have here B, capital, small b will be there, opposite. If you have here C, small c will be there. But remember here, we have 45. We have 45 as an angle. 45 as an angle. Then, what is our AB from there? Our AB. Now, don't take this. This one is in centimeters. You use these original values here, 70. So C here is 70 meters. And B is 50 meters. But remember, since they are equal, even this one will just be 50 meters. Since they are all equal. And the isosceles triangle, these two sides are equal. All right, good. Now, from there, you can get the area. Now, you can see your small b is 50. Your small c is 70. Sine of A, the angle at A is 45. That's the magic you're going to use. So now come and say 3.14 times, okay, radius of the circle. Let's measure radius of the circle here very fast. Radius of the circle, come and put at the center and adjust to the circumference. Circumference, there like that. Now it will be the radius of our circle if you try to measure. Radius of our circle. I'm having okay, here I'm having, all right, this is a 17 actually, yes, 17, and if it's 17, remember, you have to take note. So radius of this circle, radius of the circle here, the radius is 17 centimeters, because this is the accurate, it was in centimeters. But now back to meters, to be r is equal to 17 times what 1 centimeter represents is 2. So find that our radius will be 34 centimeters. Take note of that. Sorry, it will be 34 meters. Why? Because we are calculating everything in meters. Okay, so times, now our radius is 34 meters times 34 but squared minus a half times our b is 50 times our c is 70 times okay, sine of a that is 45, like that. Which answer are we going to have? Finally, you can press that on your calculator as I'm also pressing. So this one is going to be 34 squared times 3.14. That will be 3629.84 minus, let's get the area for the other one. Okay, it will be 1237.1237 point from my calculator, 4369, like that. Now let's see. This is all in meters. So now subtract. This will be minus 1237 point, okay, 4369. Okay, we have 2392. meters squared after subtracting. So 2392.4031 meters squared. Now this is the area of the shaded part. Area of shaded part. But shaded part is the area taken by pavers. Okay, now if that's the area in meters, but 1 meter has how much? Has this. Therefore, you come and multiply. 1 meter has this. What about when they are in thousands? So you come and say 2392.4031 times 35,000. We see how much this person spent. This will give us what? All right, good. So this will be now times 35,000. Oh. This will be something like 800, 8373, 4108.5. That's the money those people will spend. If you try to put the commas there without rounding,